Hello students, welcome back. In this video, we are going to discuss a comprehensive numerical example on Q operations, right? So we'll be performing NQ and DQ operations together, right, on the same Q, which we are doing with these operations we are doing in isolation. Now we'll perform them together. So this is our Q we have created and it's empty Q, right? So let's perform this NQ operation first, right? So NQ10, right? So before performing NQ, we'll check is Q full. Q is not full because R is not 4, right? So Q is not full. R is not storing the last location. That means Q is not full. If Q is not full, then we'll perform NQ operation, right? Two situations. The first situation is, right, the Q is empty, right? Full, this NQ, I'll write summary briefly. First, check full, check for full, right? Yes or no, right? The queue is not full. So two situations, right? Empty and partially full, partial full, right? Now the situation is empty. When the situation is empty, this is the first NQ or first insertion operation. In this case, we have seen that we will set F and R to 0, right? So this situation, the queue is empty, right? So we'll set F and R to 0 and insert this 10 on R location, which is 0, right? Now let's insert 20. Is Q full? No, R is not 4, right? The Q is not full. So we'll go here. Is Q empty? No, it's partially full. We'll follow this part. If the Q is partially full, what will we do? Whatever R is, we'll increment R, right? R plus plus. While doing NQ operation, I look only at R. Increment R, R plus plus, R will become 1. R was 0, it will become 1. Increment it by 1 and then go to R location in data array and insert 20 there, right? 20 inserted. 30. Again, is Q full? No, R is not 4. 4, why I am saying 4? Because 4 is the last location. If the element is present on, if R is 4 means element is present on 4th location and there is no more space to insert new element, right? Because this is the last location. That's why when R is 4, the Q is empty. Sorry, Q is full. Okay. Okay. So now in this case, the queue is not full. So it's not empty also because R is not -1. Then it's partially full. When it is partially full, simply increment R by 1. R was 1, it becomes 2, right? And then go to first increment R by 1 because if R is 1 means the element is present on location 1. The next element will go on next location, which is empty location, that is location 2. That's why first increment R by 1, then go to that location in data array and insert the number there. So 30 will be inserted here, right? So this NQ operation over, right? Now let's perform a DQ operation. Again, for DQ, the first thing which we'll do is Q empty. Before performing DQ operation, we will check if the queue is empty, right? The answer will be either yes or no. How will I check if the queue is empty? Simply check value of F. If F is -1, that means queue is empty. There is no element to be removed, so we cannot perform a DQ operation, cannot remove, so it's underflow. In this case, it was overflow, right? So this is underflow. So when inserting, check the queue is full first. While performing DQ, first check if the queue is empty. If the queue is empty, right, can't remove, right? If the queue is not empty, then first get an element, get the element in X, data of F location, and then check is uh, only element. That means have I removed the only element or more elements? More elements. Right? That we have to check. The element which he removed, was it the only element or there are more elements, right? If it is the only element, then the queue has become empty. F and R will be -1, right? If there are more elements, simply increment F by 1, right? Simply increment F by 1 f plus plus. That's it, right? So dq, right? So dq, follow this path. Is q empty? No. F is not f is not minus 1, q is not empty. So remove the element. So get that 10 out of the q, right? And then ask, was it the only element? How will I check that? Simply check f and r. F was 0, r is 2. That means they are not equal. The q is not q is containing more than one element. That means we'll follow this path. We'll increment f by 1. So f was 0. It will become 1. Right? So, okay. And then that dq operation done. dq operation done, right? So far, this is the situation of the q. F is 1 and r is 2. F is 1 and r is 2. This is the situation. Okay, or let me clearly write this. F is 1 and r is 2. So this is the situation of the Q so far. F is 1, r is 2 after this second operation. Now let's perform NQ 40 and 50. NQ 40. Is Q full? No. Is it empty? No. It's partially full. So increment r by 1. So r becomes 3. And then insert 40 on location number 3. Right? Then NQ50. Is Q full? No. Right? Is it empty? No. It's partially full. So increment r by 1. R becomes 4. And insert 50 on location 4 in data array. Right? So done. So NQ operation over. Then perform DQ twice. 2 times we have to perform DQ now. 2 times we have to perform DQ. So before performing DQ, check whether the Q is empty. Check F. F is not minus 1. The Q is not empty, not underflow. We'll follow this. Remove an element. Remove an element from F location. F is 1. So remove an element from location 1. And then check, was it the only element in the queue or there are more elements? So how will we check that? F and R will be compared. F is 1, R is 4. That means they are not same. There are more than one element. So simply increment F by 1. F was 1, it becomes 2. Right? The next element is on location 2. Then we'll perform one more DQ operation. Again, check is the queue empty. Right? Check is the queue empty. Check F. F is not minus 1, so the queue is not empty. Remove the element from data array. Right? On F location, F is 2. Data of 2 will give us 30. Right? And this was not the only element. So because there are more elements, so we'll increment F by 1. So F becomes 3. F becomes 3. So this DQ twice over. So let me rewrite this clearly. After fourth operation, F is 3, R is 4. F is 3 and R is 4. Right? So now next fifth operation, NQ 60. So we'll perform. Is Q full? How will I check? What is R? Is R equal to 4? That's how I'll do. R is 4. That means R is last location. R is storing the index of last location. That means there is an element present on the last location and there is no more space here, right? So that's why I'll conclude that Q is full and it is overflow, and I'll quit here only, right? Q full, right? On this I'll not check for this because here only the Q is full. So this operation over, right? So thus we perform this 5 operations. But the problem with this is this is called as linear queue. This queue which we have seen is called as linear queue. Why it is called as linear queue? Because F and R were incremented in the linear fashion. Both were growing in this direction only, right? So F, when removing or dequeuing after performing dequeue, we were saying F equal to F plus 1, and to insert or enqueue, we are saying R equal to R plus 1, R equal to R plus 1, and F equal to F plus 1. That was the increment, and it's a linear increment, right? Both F and R were growing in this direction, right? So that's why it is called as linear queue, right? Both F and R were growing in this direction only. You see, F was 1, then F became 2. If you perform one more DQ operation, F will become 3, right? And when performing NQ, R was 0, then R became 1, then R became 2. R was growing like this only, F was growing like this only, right? So the increment is linear, right, for F and R both, right? So that's why this queue is called as linear queue. Now, why we are not able to insert 60? Because the queue is full. The queue full notation here is if R is equal to last location, the queue is full. But is the queue actually full? If you see this location is empty, this location is empty, this location is also empty because we have removed these elements, right? For us, they are not in the queue. That means these three locations are empty. Though these three locations are empty, and just by looking at the last location, if R is last location, we are concluding that the queue is full, right? Though the queue is having space from the beginning, right? But if R is 4, we are concluding that the queue is full. So this is the drawback of this queue, drawback. This is the drawback of this queue, which is linear queue. This is the drawback of linear queue. Though there is space from the beginning, if R is equal to last location, we conclude that the queue is full. And this drawback can be overcome by using circular queue concept, which we'll see in the subsequent videos. So this was an operation to show the comprehensive NQ DQ process, and I hope you will enjoy this, you would like this, and we'll see a comprehensive program, complete program on NQ and DQ operation by operations on Q using arrays, or Q implemented using arrays, in the next video. So see you there. Thank you.